Hi, welcome back to my channel. Today we continue Chapter 2, Forces and Motion 1 on Topic 2.2, Motion Graph Part 1. Okay, in 2.1, we discuss how to analyze motion by determining the displacement, velocity, and acceleration. So based on the data that we recorded, actually we can represent all the data in form of graphs. So in this topic, we will discuss three types of graph: displacement against time graph, velocity against time graph, and acceleration against time graph. So analysis of graph is important to understand the type of linear motion of an object, because later a graph will be given. Based on the graph, you must be able to state a type of motion of an object. Okay, let's look at the first type of the graph, displacement against time graph. So for displacement against time graph, we can get displacement against time graph here. So displacement, the symbol used is small s, unit is meter. Time taken, the symbol is t, unit is second. So the first graph shows a horizontal line. So this one shows that displacement is constant. What is the meaning of constant displacement? Meaning the object stays at the same position or not moving. Thus, based on this graph, we can state type of motion of the object as object at rest or stationary. Okay, let's say we have the second graph here. Okay, so what we can say about the type of motion? Before that, let's look at what is represented by the gradient of the graph. For this one, gradient is 0. Okay, so here, displacement. What is the displacement against time graph? Shows a straight line past to origin. Okay, let's say we draw a triangle to determine the gradient of the graph. The vertical height of the triangle is b. The horizontal width of the triangle is a. Thus, the gradient of the graph equals to b divided by a, and the unit is meter divided by second. Thus, we get the gradient equals to b over a, and the unit is meter second to the power -1. As you can see, this unit we have discussed in chapter 1. This unit, meter second -1, is a unit for velocity. So what we can conclude based on this calculation, so we can say that the gradient of the graph for s against the graph is equals to velocity of the object. So from the graph here, we get only one constant gradient or constant velocity. Thus, the type of motion is uniform velocity or constant velocity. Okay. Okay, the third one you can get here is the curve graph. Okay, it curves downwards. Okay, so what we can say about the gradient of the graph? So for this one, you want to determine the gradient of a curve graph, you need to determine gradient at certain point, because for curve graph, gradient is not constant. For a straight line, you can just simply draw one large triangle because gradient is constant. But for curve graph, we cannot draw one large triangle because at different point, different gradient. So based on the triangle that we draw, actually the technique to determine the gradient is you must draw a tangent first. Okay, so you draw a triangle below the tangent that you draw, tangent at certain point. Okay, normally for curve graph, we will mention like gradient at point A, gradient at point B. Okay, so you can see from this point to this point, the shape of the triangle shows that gradient increases. Just now we have mentioned that gradient equals to velocity. So when gradient increases, meaning velocity increases. So when the velocity increases, the object accelerates. So based on this graph, the type of motion is uniform acceleration. Okay. Okay, the second graph is velocity against time graph, V against t graph. So for V against t graph, if the shape is like this, horizontal line, meaning velocity remains the same throughout. Okay, so constant velocity or uniform velocity. The second one, we have a line, a straight line pass through origin. So we can draw a triangle to determine the gradient. So what we can get from the gradient of the graph, for this graph, gradient equals to B divided by A. The unit is meter second negative 1 divided by second. Simplify the unit. Thus we get gradient equals to B divided by A, meter second to the power negative 2. As we discussed earlier in chapter 1, meter second negative 2 is the unit for acceleration. Thus, we can conclude that gradient of the graph V against t is equals to acceleration. So this straight line graph produces one constant gradient, thus constant acceleration. So the type of motion is object moving with uniform acceleration. Okay. And then the third graph, you can see the graph has a negative gradient but still a straight line graph. So what we can say from this graph, so the gradient is negative and straight line, thus object moving with uniform decreasing velocity. What else we can determine from here? Area under the graph. So area under the graph equals to area of this triangle. So the formula is half times C times D. What happened to the unit? Unit of C is meter second to negative 1. Unit of D is second. Thus we get half CD meter, because second negative 1 and second power 1 is already cancelled. So we get the unit is meter. So the unit meter means area under the graph is equals to displacement. So for V against t graph, what we can get from the graph? The gradient of the graph equals to acceleration and area under the graph equals to displacement. Okay, the third graph, acceleration against time graph. Look at the first graph. The value of A or acceleration, it always equals to 0. Meaning object does not accelerate. So object moving with 0 acceleration, or we can also say it as a uniform velocity. So no change in velocity, so 0 acceleration. Okay, second one. A horizontal line showing that the object moving at 1 acceleration or constant acceleration. So the type of motion is object moving with uniform acceleration. Okay, and the third one, you can see a straight line pass to origin. So what we can say about the graph, object moving with increasing acceleration. Okay. Okay, let's look at example. Okay, how to analyze the graph in order to determine distance, displacement, and velocity. The first example is displacement against time graph. So given the graph is like this. Okay, so now we want to analyze part by part. As you can see, the object is moving from A to B, B to C, C to D, D to E, and E to F. You can see the different shape of the graph. Okay, so you need to remember what we have discussed earlier about the type of motion based on the shape of the graph given for ST graph. Let's look at the first part, AB. For section AB, a straight line passes through origin. The gradient of ST graph equals to velocity. This is positive gradient and constant gradient. This one is constant velocity. So from the gradient of the graph, we can calculate. Let's say the gradient here is 100, the height of the triangle, 100 divided by 5. Or 100 minus 0 divided by 5 minus 0. Thus we get 20 meter second negative 1. So for AB, velocity of motorcycle is 20 meter per second to the right. So we can take positive sign as is to the right. Okay. Okay, next BC. So for BC, you can see the displacement is constant, meaning motorcycle not moving, stay at same position. So motorcycle stop for how many seconds? 5 to 8, meaning 3 seconds. Okay, so gradient of the graph is 0, therefore velocity is 0. So object at rest normally is velocity equals to 0. Okay, so for CD, a straight line but negative gradient. So you can draw a triangle below the line and calculate the gradient. So motorcycle stationary at initial point, here C, stationary here. Then gradient of the graph, okay, we want to discuss about CD first. This one, I just skip. Okay, sorry here. So this is the CD part. So for CD, motorcycle is ridden back to initial point A in 4 seconds. Okay, so from C to D, you can see at D, displacement becomes 0. Displacement 0 means the motorcycle returned to original position. So the gradient of the graph, you can calculate here, is 100 minus 0, or 0 minus 100. Divide by 12 minus 8. The value is negative, so you get negative 25 meter per second. Therefore, velocity of motorcycle is 25 meter per second to the left. So the negative sign meaning the motorcycle is moving to the left. Okay, reverse direction. Okay, next for DE, the value of S equals to 0. Meaning the motorcycle stationary at initial point. Just now back to original point at D and then stay for 2 seconds at point D. Okay, so gradient equals to 0, therefore velocity 0. And then EF, so from E to F you can see displacement increase but the value is negative. So you can calculate the gradient. Okay, the gradient for this part. So motorcycle is ridden to the left for distance 50 meter from 6 seconds. Continue moving to the left. Okay, so gradient equals to negative 50 minus 0 divided by 20 minus 14. So you can draw a triangle below here, below this line EF. Okay, so we get negative 8.33 meter per second. Therefore, velocity of the motorcycle is 8.33 meter per second to the left. Okay. So what we can get from here? We can calculate distance travel. So for distance travel for the whole motion of the motorcycle is AB plus BC plus CD plus DE plus EF. Okay, so for AB, okay, distance travel at B is 100, meaning AB is 100. BC, 0 because not moving. CD, also 100. DE, 0 because not moving. EF, 50. So for distance, no need to consider direction. You just total up length of all the path traveled by the motorcycle. So you get 250 meter. For displacement, this is vector. We take to the right is positive, left is negative. So AB, positive direction, so 100. BC, 0. CD, opposite direction, negative 100. So minus 100 here. And then DE, 0. EF also negative, so minus 50. So 100 minus 100 minus 50. Because, and then we get negative 50 meter. So where is the position of the motorcycle at the end? Meaning it is 50 meter to the left of the original position or initial point. Okay, now look at second example. This is a VT graph. Okay, so for VT graph, given this one, acceleration given, semua you can refer to the textbook for the whole example. Okay. Okay, we look at for the time interval 0 to 50 because here no mention about point A, B, C or what. So we refer to the time interval. Okay, time interval 0 to 50 seconds from here. Okay, so gradient of the graph, because horizontal line, gradient 0. Gradient 0 means acceleration 0, or we can say bicycle is moving to the right with uniform velocity of 10 meters second negative 1. So maintain 10 meters second negative 1 for 50 seconds. Okay. Next, from 50 to 70. So you can see we have this one, a straight line, positive gradient. Thus the gradient of the graph, we can draw a triangle here below this line. Okay, so you draw a triangle below this line, you will get is 15 minus 10, 70 minus 50 for the width. Thus we get this one. So 0.25 meters second negative 2. Therefore, the bicycle is moving to the right with uniform acceleration of 0.25 meters second negative 2. Okay, for 70 to 100. So you can see this is also a straight line, but negative value, negative gradient. Thus the gradient equals to, okay, draw a triangle below this line. So we'll get is 0 minus 15 divided by 100 minus 70. So we get is negative 0.5 meters second negative 2. So acceleration of the bicycle is negative 0.5 meters second negative 2. The sign, which is negative, shows that velocity of the bicycle gradually decreases. So you can see from here 15, then becomes 0 here, so decrease. Okay, the bicycle accelerate at 0.5 meters second negative 2. Negative value shows in opposite direction to the motion of the bicycle. Okay, so you can see from here, actually when travel from 15 meters second negative 1 to 0, so actually it also accelerate, but accelerate in opposite direction. Okay, in other words, we can say deceleration. Okay, from 100 to 120, this one 0 velocity, meaning bicycle stop and rest for 20 seconds. From 120 to 150, so you can see the line of graph is below here. Okay, velocity increases but in opposite direction. So gradient of the graph we get is, you calculate, just draw a triangle below this line, or use this triangle also can. Okay, this triangle. Okay, so you will get is -9 minus 0 divided by 150 minus 120. So you get -0.3 meter second -2. Thus, acceleration of the bicycle is -0.3 meter second -2. So velocity of the bicycle gradually increases. So the bicycle accelerate at 0.3 meter second -2 in the same direction as the motion of bicycle. Okay. Okay, what else we can determine from the graph? Just now we have discussed for v against the graph, the gradient equals to acceleration, and the area under the graph actually equals to distance or displacement. Okay, let's say we want to determine the distance travel and displacement of the bicycle. So we can calculate area under the graph. Okay, you can divide it to a few sections so that easy to calculate. So from here we can put it as L1, L2, L3 and L4. So for L1 is 550 minus 10. This square. Okay, so 50 times 10. Okay. So we have 500 meter. For L2, use a trapezium formula, half times 10 plus 15 times 10. Okay, so we get is 250 meter. L3 is this triangle, so half times 30 times 15, so we get is 225 meter. L4, this triangle, half times 30 times 9, so we get is 135 meter. So the total distance, you just total up all, meaning L1 plus L2 plus L3 plus L4. Okay, so we get is 1,110 meter. Okay, now you want to calculate displacement. So you need to identify displacement to the right and displacement to the left. For VT graph, the one that at a positive part of the axis is in the same direction. The one that below, which is negative part of the v-axis, this one is opposite direction. So meaning L1 plus L2 plus L3 minus L4. Okay, thus we get here total displacement 500 plus 250 plus 225 minus 135. So need to minus the one which is opposite direction. So we get 840 meter. The answer is positive, meaning to the right. Okay, so this is how we analyze the graph or motion graph in order to determine the value of velocity, acceleration, distance, displacement. Okay, so you must be able to solve problems involving motion graph, okay, by using all the properties that we discussed before. Okay, I will stop here, so I will continue in the next part 2. Don't forget to subscribe for more oncoming videos. Bye.